first thing is x minus 1 quantity raised to the 10th power, that is a polynomial. And if it takes some convincing for yourself, like think about if it was x minus 1 to the 2nd power, you would FOIL this out. And when you FOIL it out, you get x squared minus 2x plus 1. And hopefully when you look at that, you're like, okay, I have a polynomial. So if you look at x minus 1 to the 10th, you would have to FOIL it out multiple times, but you would eventually get an expanded form that looks like the polynomials that you are familiar with. So you really want to realize here that you have x to the first power. It is a polynomial when you expand it out. So the question of, is it continuous? Yes, it is continuous on the closed interval 0 to 2, and that is because f is a polynomial. Okay, and again, in your mind, you're kind of thinking, okay, well, we don't have a denominator, we don't have a radicand, we don't have a natural log, so it's perfectly well defined, and it is a continuous function. Okay, now the question of differentiable, that is also going to be a yes, and here is why. When you look at the derivative, you would use the general power rule because you have parentheses to a number, so the derivative would be 10 times x minus 1 to the 9th. And again, if you were to expand that out, it's going to be perfectly well defined for all real numbers. So this derivative is defined for all real numbers, so yes, it is differentiable on the open interval 0 to 2. So both assumptions of the mean value theorem apply or are satisfied here. So we would say that the mean value theorem applies. And then once we know that it applies, we need to actually find the C value that satisfies the conclusion. So we will look at f of a, which is going to be f of 0. So plugging in here, we have 0 minus 1 to the 10th. So that's negative 1 to the 10th. A negative raised to an even power will just give us a positive 1. And then we have f of b, which is going to be f of 2. So we're looking at 2 minus 1 to the 10th, which is 1 to the 10th, which is 1. Now, it is interesting to note here that if the question had been, does Rolle's theorem apply, here you have f of a is equal to f of b. So not only does the mean value theorem apply, but also Rolle's theorem applies as well. But we'll stay focused here on the fact that we're trying to find our mean value theorem. So we look at f prime of c equal to f of b minus f of a over b minus a. Now, when you plug in your f of a and f of b, you're just going to get 1 minus 1, and then in the denominator, 2 minus 0. So that is just going to give us 0 on the right-hand side. Now, if we are going to formally work through what our f prime of c is, we would take our derivative and we would replace a c for the x's. So that's going to give us 10 times x will now be a c minus 1 to the 9th power. So the derivative that we're looking at for f prime of c is going to look like 10 times c minus 1 to the 9th power. Now, to solve this equation, the first thing you want to do is get rid of the 10. So I would divide both sides by 10. And then to get rid of the 9th power, I would want to take the 9th root of both sides. And that gives us c minus 1 is equal to 0. Add 1 to both sides, we get c is equal to 1. Now again, you always want to make sure that that c value is inside of the interval. Again, the interval we're looking at is from 0 to 2, and that c value is inside the interval. So our answer would be that the mean value theorem applies and that the c value is equal to 1.